This video is an overview of solving linear equations. I usually teach solving linear equations using these 4 steps. Step 1 is clear parentheses and combine like terms on each side. Clearing parentheses means you're going to use the distributive property to break apart the parentheses and isolate the terms on the inside. Combine like terms means we're going to add our variables together and add our numbers together. Now, you don't always do anything for step 1. Sometimes some problems don't have parentheses or any like terms, so you kind of move on to step 2. But the point of step 1 is to simplify each side of the equation before you actually start doing the algebra. Step 2 says get all the x's on one side and all the constants on the other. Again, by x's, I just mean your variables. We want to get all of our variables on one side. Everything without a variable, the constants would be the numbers without any variables. You want to get those on the opposite side. In this step, we do this by adding or subtracting quantities on both sides of an equation. In step 3, you should have all your variables on one side, so your job now is to isolate that variable or isolate x. And we do that step with multiplication or division. Keep in mind in both these steps here, we're trying to apply the opposite operation to what we have in order to get rid of quantities on one side and move them to the other. So you add if you have a negative, or you divide if you have a number being multiplied by. And in your last step, keep in mind you can always check your answer. If you get an answer like x equals 5, for example, that means 5 is the number that when you plug it in for x, you get a true statement. A true statement meaning you get the same number on both sides of the equation. So we're going to go through and use some of these steps. I'm probably not going to check the solution on all of them, but keep in mind you can always do that. So here's our problem here on number A, part A, solve for x. So notice we have a number next to parentheses, so we have some distribution to do there. So we're going to start with that. We're going to take this -2, and we're going to multiply by the x and the -4. So -2 times x is -2x. -2 times -4 is a +8. And we didn't do anything on the other side, so we'll just rewrite it. And that's actually it for step 1. We cleared the parentheses. There were no like terms on each side to combine, right? Over here we have x's and numbers, so we can't combine those. X's and constants, can't combine those. So we're in step 2 now, where we want to get all of our x's onto one side. We could either move the -2x over here or move the 5x over here. Honestly, it doesn't matter. As long as you pick a step and your individual steps are correct, you'll get the right answer. So let's go ahead and get rid of this 5x. I'm going to subtract it from both sides. Keep in mind, if I have a 5x and I want to get rid of it, I want to subtract 5x. So this step makes sense because those things will go away. And if I subtract 5x from one side, I have to do the same thing on the opposite side. Okay, so over here, we can combine these. So we get -7x plus 8 equals -6. All of our x's, all of our variables are on one side. So we want to get everything without a variable to the opposite side. So this 8 needs to go. And because it's positive, we're going to subtract, subtract 8 from both sides. Okay, so they cancel out here. That's how we know that step works. We get a -7x equals -6, -8. That'll give us a -14. So that's the end of step 2, right? Now we have all of our variables on one side, everything without a variable on the other side. Now we want to isolate x. What's happening between the -7 and the x here is multiplication. We break multiplication by dividing. We want to divide by everything that's not x, so the negative and the 7. Whatever we do to one side, we do the same thing to the other. So notice these divide out to give us 1, so essentially they go away. And we're left with x equals -14 over 7 is a +2. So that should be our answer. So we're claiming that when x is 2, we have a true statement. Let's do a quick check just to see if that works. So we're going to replace all the x's with a 2. So here 2 minus 4 is -2, so we have -2 times -2. Over here 5 times 2 is 10, and then we have a -6. -2 times -2 is +4. 10 minus 6 is also +4. So it checks out. We know it works now because we plugged it in. We got a true statement. So that's all the steps. Let's go through one more example using those steps, part B here. Notice we have 2 sets of parentheses, so we're going to distribute on both of these. So 4 times x is 4x. 4 times 2 is 8. Make sure here we redistribute the negative with the 2, so we're going to get a -2x. -2 times 3 is a -6. So our parentheses are clear. We're still in step 1 though, because Here's our equal sign. Over here we have two sets of like terms. The 4x and the minus 2x can combine. The 8 and the 6 can combine. So 4 minus 2x will give us a 2x. 8 minus 6 will give us a 2. And that's the end of step 1. Now each side is as simplified as it can get, and we have to start moving things. So notice all of our x's are already over here. So we're in step 2, all of our x's on one side. Everything without an x needs to go to the other side. So we're going to subtract this 2 over. 10 minus 2 is 8. That's the end of step 2, and now we want to get x by itself. This is 2 times x. We break multiplication with division, so we divide by this 2. We get x equals 4. So we could check it again, but I'll leave that exercise to you. But it's pretty easy. You plug it in, try to get something like, in this case, 10 equals 10. Okay, so that's the basic idea of the 1, 2, 3, 4 steps. We should take a quick look at a problem with some fractions. We can do everything exactly the same as before, but when you work with fractions, then you have to kind of find common denominators along the way. And we have this freedom in algebra where we can multiply both sides of an equation by whatever number we choose. So it makes sense in this case. We can actually get rid of the denominators by multiplying both sides by the lowest common denominator, or I guess more accurately it would be the lowest common multiple of the denominators. So the smallest number that all your denominators divide into. So in this case, our denominators are 2 and 4, right? 2, 4, 4, so 2 and 4. What's the smallest number that 2 and 4 both divide into? Well, that number would be 4, right? 4 is divisible by 4, and so is 2. So we're actually going to start by multiplying both sides by 4. So I'll show it like this real quick. When we multiply this side by 4, the 4 is going to be multiplied by the 1/2 x and the 3/4. It's basically going to be distributed. So I like to write them separate. So 4 times 1/2 x plus 4 times 3/4 equals 4 times -1/4. So literally every term is going to be multiplied by 4. And now when we do this, we can either cross multiply or multiply and divide. Let's just kind of make it simple here. 4 times 1/2, that's the same thing as taking half of 4, which would be 2. So we get 2x. Here we have a 4 on top and a 4 on bottom. So these 4's cancel, and it just leaves us with a positive 3, or plus 3. Same thing over here. The 4 on top, 4 on bottom, they cancel. So we end up with a -1. This equation looks different from what we started, but it's technically equivalent. So in this first step, any equation that starts with fractions, if you find the lowest common multiple of the denominators, and you multiply it on both sides, you should be able to cancel out all the denominators and then have an equation that's equivalent, but it has no fractions. So if we continue our steps, we're in step 2 here. X's are over here. We want to get our non-x's to the other side. So we're going to subtract 3 from both sides. So 2x equals -4. Last step, divide by 2 on both sides. And we get x equals -2. Okay, so that's how you deal with equations with fractions. So last couple things to look at. We're going to apply this to a problem that you'll see in our statistics section on the normal distribution. We'll have this formula that we convert raw scores to z-scores. Z equals x minus the mean over the standard deviation. This is the Greek letter mu standing for the population mean, Greek letter sigma standing for the population standard deviation. If this doesn't make sense to you right now, it's okay, because we're just going to do the algebra part. So basically this formula has 4 pieces, and at any given time, if you're given 3 of them, you can solve for the 4th. So this problem we're going to do here on part A says, given the mean is 20, the standard deviation is 6, and the z-score is 1.32, solve for x. So basically, what raw score would give us a z-score of 1.32 if this is our mean and this is our standard deviation? So we're just going to take the values we have and plug them in. So let me rewrite the equation one more time. Okay, that's our equation. Now our z-score is 1.32, so we're plugging that in for z. We're solving for x, so let's leave that alone, minus the mean, which was 20, and the standard deviation, which was 6. Okay, so we're just taking this equation, plugging in the mean, standard deviation, and the z-score that they gave us. And now we want to solve this equation for x. So we're kind of back to what we were just talking about. We have an equation that has a fraction in it. We can always start by multiplying both sides by the lowest common multiple of the fractions. In this case, of the denominators, that is. In this case, there is only one denominator, it's 6, so we're going to multiply both sides by 6. So on the left here, we have 6 times 1.32, and I'll just throw that in the calculator real quick. 7.92 is what I'm getting. Over here, the 6 on top and 6 on bottom, these cancel, and we're just left with x minus 20. And our last step, if you want to get x by itself, is add 20 to both sides. And we get x equals 27.92. So you'll be doing problems fairly similar to this in our last section in statistics on the normal distribution. Okay, but the point is we can apply these algebra skills that we just learned to an applied problem here when we're talking about z-scores and raw scores. Now, that was a very specific case where we had a z, a mean, and a standard deviation, and then we solved for the raw score. The formula itself is, let me just rewrite it one more time. This formula is in terms of, or it's solved for z, right? So basically given x, the mean, and the standard deviation, what is z? But we can do algebra on this formula itself and solve it for x instead. So this last topic here is we're not solving for specific answers like x equals 27.92. We're actually doing algebra on an equation with maybe just variables, right? In this case, we have all variables, but we're still going to perform algebra and we're going to isolate x. What it means in that case to isolate x is to get x in terms of the other variables. So let me show you what that looks like. We want to solve this formula for x, so we want to get x by itself. We're actually going to do pretty much the same steps we did before. And in this case, we're going to multiply both sides by the lowest common multiple of the denominators. The denominator is just sigma in this case, right? The standard deviation. So we're going to multiply both sides by that number sigma. And what's going to happen is over here, we're going to have sigma z, right? Which basically, I'll put a dot there. Those are being multiplied together, sigma times z. And this will equal, over here, the sigmas will cancel, and we'll have x minus the mean. So it looks a little weird, but all we did is multiply both sides by the sigma value, and it's being multiplied by the z now. And if we want to get x by itself, x is being subtracted, or this number is being subtracted from x, and we want to get rid of this by adding it to both sides. Right, so this cancels out, and now we have a new formula, x equals, I'll just write it as sigma z, right? Those are being multiplied together, plus the mean. What this formula does is it's the same as the one above, except now given sigma, z, and mu, or the standard deviation, z-score, and a mean, we can find the raw score that goes with it. So we can actually do the problem above without doing the algebra if we have this formula. The point of this problem here, though, is to realize that we can perform algebra on abstract quantities like this, right? For any given sigma, z, and mu, we can find x now. We'll look at one more example of this, applying algebra to formulas. This is one we see a lot in when we're talking about graphing in x and y. So in this case, we have this equation 4x minus 2y equals negative 16, and we want to solve this equation for y. Notice we have a y and an x, so if we're getting y by itself, that means part of our answer is going to have an x in it still, which is okay, but that's kind of the similar situation that we had before. So if we want to isolate our y value, we want to start by isolating the minus 2y. And that means this 4x needs to go to the opposite side. Basically, everything that's not y needs to go to the other side. So we're going to start by subtracting 4x from both sides. Okay, so these cancel out. Make sure you're careful here. Minus 2y is what we have left over. Now over here, we have minus 16 and minus 4x. Those aren't like terms. We can't combine those because we have, constants and variables. So we're left with literally minus 16 minus 4x, or it's probably better if we write the x value first. So I'm going to write it as minus 4x minus 16. Okay, you could switch the order here as long as you get the minus on both. But we like it this way because if you recall our slope-intercept form, y equals mx plus b, we like to have our x's first. Okay, so now we want to get y by itself, so we need to get rid of this negative 2. We're going to do that by dividing, and I'm going to divide each of these separately by negative 2. Basically, everything needs to be divided by negative 2. Here, the negative 2's cancel, so we get y equals. Negative 4 over negative 2 is a positive 2x, and negative 16 over negative 2 is a plus 8. So here we have it. Our goal is to get y by itself. We just did. This equation that we started with, 4x minus 2y equals negative 16, is equivalent to this equation. But just like above, we put it in a different form now, right? We solved it for y, so it's in terms of one specific variable. All right, so that's it for this video. We're just covering basic solving equations and then kind of solving formulas for different variables. These are some of the key algebra skills that will basically be with you in any math class, but definitely kind of carrying through this course, you'll see some algebra here and there, and hopefully after this little memory jogger, you'll be up to it. So hope this helps. Let me know if you have any questions, and keep up the good work.